right, so looking at number 1, we have to evaluate the indicated function for f and g. So this tells us that we need to subtract f minus g. So we would take our function f of x, which is x squared plus 2, and subtract the function g of x, which is x minus 3. We have to be careful when we subtract because we have to distribute that negative to both things on the inside. So this would be x squared plus 2 minus x plus 3. I'm going to combine like terms. So x squared minus x plus 5. And then I have to plug in 4t. So I'm going to plug in 4t where all my x's are. So 4t squared minus 4t plus 5. And then the last thing I have to do to simplify is just square that 4t. So 4 squared is 16t squared minus 4t plus 5. All right, let's look at number 2. Here we have to find f of g and the domain. So f of g means that we have to take g and put it inside f. So I'm going to take my entire function of g, put it in the x, in the f of x. So I have the square root of x to the 5th power plus 2. So this is my f of g. And then the second thing I have to do here is find the domain. So anything under a radical can't be negative. So this has to be greater than or equal to 0. Because it could be 0, it just can't be negative. So I'm going to set x to the 5th power plus 2 greater than or equal to 0. And then just solve for x from here. So subtract 2 on both sides. X to the 5th power is greater than or equal to negative 2. And then just take the 5th root of both sides. So x is greater than or equal to the 5th root of negative 2. So you could see your answer like this because remember it's multiple choice. Or you could see it in interval notation. So x has to be greater than this. So it would be the 5th root of negative 2 to infinity. And it's including, so this would be a bracket.
I thought you couldn't have a negative as a radical.
But it's the 5th root. So if you have an odd radical, you could have a negative under. But that's a good point. If it was just a square root, like you were taking the square root of both sides, then your domain here would be all real numbers because that would be imaginary, so it wouldn't be part of it. All right, any questions there? Number 3 then. Determine whether the function has an inverse function. If it does, find the inverse. So to find the inverse, we just flip our x and y. So we make this fancy f of x, y, and then just switch x and y. So this is x is equal to the square root of 2y plus 6. And then we have to solve for y. So what should I do first to solve for y? Square both sides. So that cancels. So x squared is equal to 2y plus 6. What should I do next? Move the 6. So I'm going to subtract 6 on both sides. So x squared minus 6 is equal to 2y. Now what should I do next? Divide by 2. So x squared minus 6 over 2 is equal to our inverse. So remember, the midterm is multiple choice, so you could see it like this, or if they simplified it a little bit more, it would be x squared over 2 minus 3. Because it would be like x squared divided by 2 and negative 6 divided by 2. So you could see it like either one of these. All right, let's look at number 4. Determine if the function is even, odd, or neither. So to determine if the function's even, odd, or neither, we want to plug in 2 numbers. So a number and its opposite. A good one to always plug in would be like 2 and negative 2. If you get the same answer, it's going to be even. If you get opposite answers, it'll be odd. And if you get answers that are not alike, then it would be neither. So let's plug in 2 and negative 2. So I have the cubed root of 2 minus 6, so this would be the cubed root of negative 4. Yeah. And then if we plug in negative 2, we have the cubed root of negative 2 minus 6, so this would be the cubed root of negative 8. And the cubed root of negative 8 is negative 2. But once you get to this step, you can see that these are not the same number. So what would our answer be? Neither. All right, number 5. So we're finding the inverse. So again, I need to switch x and y. So x is equal to y to the 7th power minus 6. What should I do first? Add 6. So x plus 6 is equal to y to the 7th power. And then I'm just going to take the 7th root of both sides to get rid of that 7th power. So I have my inverse is equal to the 7th root of x plus 6. All right, number 6, we're finding the domain. So we always want to check out when doing the domain, if we have a denominator, our denominator has to be not equal to 0. And then if we have something in the square root, we would set whatever's under our square root greater than or equal to 0. So these are 2 instances that we have to keep an eye out for when we're doing domain. So here, we have something in the denominator, it's a fraction, so we just set our denominator not equal to 0. So x squared plus 1 does not equal 0. All right, so next we have to solve for x, so I'm going to subtract 1 on both sides. So x squared does not equal negative 1. Take the square root. X does not equal the square root of negative 1. Can I take the square root of negative 1? No. So since this is not a real thing, this is imaginary, my domain is going to be all real numbers. So negative infinity to infinity. Because I can't plug in a real number into x here, that'll give me 0. And then for b, since we have a radical, we set what's under the radical greater than or equal to 0. Okay, so x squared minus 16 is greater than or equal to 0. Add 16 to both sides. X squared is greater than or equal to 16. Take the square root. So x is greater than or equal to, what do I need if I take the square root of both sides? Plus or minus. So plus or minus 4. So sometimes you could see your domain written like this if it were multiple choice. Sometimes you could see it in interval notation. So how would I write x is greater than or equal to negative 4, negative plus or minus 4 as an interval? We want to see if we're including numbers inside negative 4 and positive 4 or outside negative 4 and positive 4. Well, let's check. So a good number to always check would be 0, because 0 is in the middle. So if I plug in 0, I could see if it works or not. So 0 squared minus 16 would give me a negative number. So in the middle does not work. So that means the outsides would work. So my domain would be from negative infinity to negative 4, and then from 4 to infinity. Yeah. You could see it with the little union in between. Determine whether the lines passing through the points are parallel, perpendicular, or neither. So to determine if lines are parallel, perpendicular, or neither, we need to know their slopes. If the slopes are the same, they're parallel. If they're opposite reciprocals, they're perpendicular. And if they have nothing to do with each other, then it's going to be neither. So let's find our slopes. What formula do we use for slope? Awesome. y2 minus y1 over x2 minus x1. So I have x1, y1, x2, y2. So 0 minus negative 4 over 7 minus 2. So this would be 4 over 5. So that's the slope of line 1. Then we have to find the slope of line 2. So again, I have x1, y1, x2, y2. Plug it into my formula. 0 minus negative 8 over 4 minus 14. So this would be 8 over negative 10. This simplifies to 4 over negative 5. What do you think? Are these parallel, perpendicular, or neither? Neither. So these are not the same and they're not opposite reciprocals, so our lines are neither parallel nor perpendicular. Neither. So an example of opposite reciprocal would be if you have like 2 over 3 and then negative 3 over 2. So it's like the flip of it. All right, determine the x-intercepts. What do I need to do to find x-intercepts?
Find the x-intercepts at y to 0.
Set y to 0, and then I'm going to need to factor it. So I'm going to make y 0, and to solve this, I'm going to need a factor. How should I start to factor this one? Take out 2. Always look and see if you have a greatest common factor to take out first. That'll make factoring a lot easier. So always look for that greatest common factor. So I'm going to divide everything by 2. I have x squared minus 2x minus 8. And then do I have two factors of negative 8 that add to negative 2? What are they? Negative 4 and 2. So I would have x minus 4 and x plus 2. So because I took out just 2 and not a 2x, I could divide both sides by 2. And 0 divided by 2 is just 0. So I would have x minus 4 times x plus 2 is equal to 0. So that 2 we can just get rid of. If I took out an x, I would need to set that x equal to 0 also. So that's the difference. Like if I took out an x here, that x is a value. So you would have to set that equal to 0. But since it's just 2, you can just divide it out and get rid of it. If it's just 2, you don't keep it. You can get rid of it. If there's an x, you need to keep it. Because that would be like, you would have to set x equal to 0. So x minus 4 is equal to 0. X plus 2 is equal to 0. X is equal to 4. X is equal to negative 2. So if it asks for x-intercepts, most likely you'll see your answer as a coordinate point. So how would we write these as points? 4, 0, and negative 2, 0 also. Awesome. So for x-intercepts, you'll have a value in your x because you plugged in 0 for y. All right, number 9. Find the zeros and state the multiplicity. What do I need to do to find zeros? Awesome. So to find zeros, that's the same thing I just did. I'm going to need to factor. So I just set this equal to 0. Whenever you have 4 terms, you can always check to see if you can factor by grouping. So group the first 2, group the second 2. So in my first group, what's the greatest common factor that I could take out? X squared. So I have x squared, and then I'm left with x minus 5. In the second group, what's the greatest common factor I can take out? Negative 4. Awesome. And then I'm left with x minus 5. So since my insides are the same, I know I can factor by grouping here. So the outsides go together as x squared minus 4. And then the insides combine as 1. So that would just be x minus 5. And it's equal to 0. From here, we just set each piece equal to 0. So x squared minus 4 is equal to 0. X minus 5 is equal to 0. And solve for x. So I'm going to add 4 on both sides. X squared is equal to 4. Take the square root. So what's x equal to?
2.
Just 2. Plus or minus 2. And the second one, I add 5 to both sides. So x is equal to 5. So my zeros are x is equal to -2, +2, and 5. Do I have any multiplicity here?
Multiplicity of 0? No.
Do any of my zeros repeat?
No.
No. So it would either say no multiplicity or multiplicity of 1 because you just have 1 of each of them.
And it's clever though. The x.
So this would be multiplicity of 1 because I only have 1 of each answer. All right, let's look at number 10. So you have to find the slope and y-intercept of the equations of the lines. So I have an equation. I want this to be in y equals mx plus b form. That way I can clearly see that my slope is my m and my y-intercept is my b. So all I have to do is rearrange this equation. So what should I do first to get it and to be this y equals mx plus b form?
You have to subtract the 16 on both sides, then add an 8x on both.
Awesome. I'm going to add 8x and subtract 16 on both sides. So that'll move it to the left side. So I have -4y is equal to 8x minus 16. And then what should I do next? Divide by -4. So then y is equal to -2x plus 4. So what's my slope? -2. And what's my y-intercept? 4. So slope, y-intercept. So if we had to graph this, again, if it gave you this equation, I would suggest putting it into slope-intercept form. That way it's easier to graph. You always start by graphing your y-intercept. That's where we cross the y-axis. So that would be our first point. And then the slope is -2, so it would be like -2/1. So we would go down 2 to the right 1. Down 2 to the right 1. So that would be there. So that would be our line.
If it was positive, it'd be flip.
Yeah. So if it was positive, you would go up 2 to the right 1. So if the y-intercept was a point, it would be 0, 4. All right, 11. Write the quadratic function in standard, which is vertex form. So our vertex form is y is equal to a times x minus h squared plus k. How can I get my equation here to look like vertex form? What do I need to do? We would complete the square. So I'm going to group my x terms together. So this would be -4x squared plus 16x. I'm going to leave a space for my number here that's going to help me complete the square, and then just keep that -3 outside. Do I have anything in common between -4x squared and 16x besides the x's? Any numbers in common? I'm completing the square, yeah. So I can take out a -4 from my group here. So -4 times x squared minus 4x. I'm going to leave my space still to complete the square, -3. So the little formula that we use to complete the square is b over 2 squared, where b comes from your middle term. So here this would be negative 4 over 2 squared. Can I simplify negative 4 over 2? Negative 2. So that would be negative 2 squared. When you complete the square, whatever is squared here, so that would be our x, whatever is squared here, so that would be negative 2, goes inside of our parentheses squared here. So just drop that down and drop that down. Now I just pulled this negative 2 squared out of nowhere, so I have to make sure my equation is still balanced. So negative 2 squared is 4, so I'm adding a 4 inside here. But it's inside the parentheses, so I have to multiply that times negative 4. So I'm actually subtracting 16 in here. So to keep my equation balanced, I need to add 16 to the 3. So negative 3 plus 16 would be plus 13. And that 4 stays on the outside as negative 4. And this would be vertex form.
So that whole bottom page,
Yep. So in vertex form, we can clearly see what our vertex is. So what's my vertex? Awesome. 2, 13, because you just switch the sign of your h, and then the k stays the same. So it'd be positive 2, positive 13. Let's say we were given an equation in standard form like this, so just the original equation, and it asks us to find the vertex. Oh, that's actually the next one, so that's number 12, so we'll do it there. So given an equation in standard form, and it just tells us to find the vertex, what do I need to do? Anybody remember that little formula to find the vertex?
b over 2 squared.
Negative b over 2 times a. This should be x equals. So x equals negative b over 2a, where our a and b come from here. So this is our a, this is our b. This is our c, but it doesn't really matter in our formula here. So I would have negative 4 over 2 times negative 1. So negative 4 over negative 2 would just be 2. So that gives me the x in my vertex. How do I find the y in my vertex? Plug it in. So I just take the x and plug it into all of my x's. So I have negative 2 squared plus 4 times 2 plus 11. So this would be negative 4 plus 8 plus 11. So 4 plus 11, which would be 15. So this is the formula to help you find your vertex. Another way we could find the vertex, so looking at the one before, this was 11, I think. Yeah, 11. Another way we could put this in vertex form is by finding the vertex first. So that would be negative b over 2a. What's the b here? 16. So it'd be negative 16 over 2. And what's our a? Negative 4. So this would be negative 16 over negative 8, which is 2. So my x in my vertex is 2. How do I find the y? Plug it in. So I have negative 4 times 2 squared plus 16 times 2 minus 3. So here, this would be 2 squared is 4. 4 times negative 4 is negative 16. Plus 2 times 16, that would be 32. Minus 3, so this would be 16 minus 3, which is 13. So my vertex is 2, 13. I can plug it into my vertex form here, just by plugging in, this would be h and k. So I have y is equal to a times x minus h squared plus k. And what's my a? What did I say my a was in the beginning? Negative 4. So that just goes there. So instead of completing the square, you could do it this way. You could just find the vertex and plug it in. Just for fun, looking at number 12, if it asked us to put this into vertex form, I would have y equals, what's my a for number 12? Negative 1 times x minus h. What's my h?
Plus 2.
So h is 2, so it would be minus 2
Oh, sorry, that was
squared, and then plus k, and k is 15. So that would be vertex form. So it's probably easier to find the vertex and then plug it into a vertex form rather than completing the square. But if you like completing the square, you could do that too. All right, 13. Here we have to write the vertex form of the equation of the parabola that has the indicated vertex and passes through the given point. So my vertex form is y equals a times x minus h squared plus k. My vertex is my h and k, and then the point is x and y. So I'm going to plug in h, k, and x and y, and then see what I need to do from there. So I have 7 is equal to, I don't know what a is, x is 1, h is 2, so 1 minus 2 squared, plus k, which is negative 8, so this would be minus 8. So I just plugged in h, k, and x and y. So then here we just need to solve for a. So 7 is equal to a times 1 minus 2 would be negative 1, and negative 1 squared is just 1. So that would just be a minus 8. And then add 8 to both sides. So a is equal to 15. So then when I write my vertex form of the equation, I have y is equal to 15 times x minus h, which is 2, squared plus k, which would be minus 8. So when you write your vertex form, you just plug in your h and k and your a. All right, so starting with 14, we have to perform the indicated operation and write the complex number in standard form. So standard form is a plus bi. So the real number comes first, the imaginary number comes second. So first thing we need to do is simplify our radicals, see if we can combine them at all. So I have a negative under my radical. I can take that out as an I. And then what are 2 factors of 50? 25 and 2. And 2 factors of 25? 5 and 5. So I have a pair of 5s that'll come out. If I already have a 7 on the outside, what happens to the 5 and the 7? How do I combine them? Multiply. So that would be 35i. And what stays on the inside? 2. And then do the same thing with the 40 here. So what are 2 factors of 40?
2 and 20.
2 and 20. And 2 factors of 20?
4 and 5.
4 and 5. And 2 factors of 4? 2 and 2. So do I have any pairs? I have 2 2s. All right, so 2 comes outside with the 2 that's already on the outside. Multiply, so 2 times 2 would be 4. And then what stays on the inside? 2 times 5, which would be 10. Can I combine these together? No, but I do need to write it in standard form. So 4 radical 10 plus 35I root 2. So since one of them has an I, that one goes second. All right, let's look at B. So I need to combine all my like terms. First thing I need to do is distribute.
Go back.
Yeah. So negative 3 times 8 would be negative 24. And then negative 3 times 2i would be negative 6i. And then I can just combine my like terms. So I'm going to start with my real numbers first. So 4 plus 2 minus 24 would be negative 18. And then my imaginary numbers are 3i minus 4i minus 6i. So that would be negative 7i. So that's my answer. All right, 15. We have to find the vertical and horizontal asymptotes and the domain. So my vertical asymptotes, I set the denominator equal to 0. Horizontal asymptotes, if my numerator, the degree of my numerator, is greater than the degree of the denominator, then I have no horizontal asymptote. If my degree of the numerator is less than the degree of the denominator, then my horizontal asymptote is y is equal to 0. And then if they're the same, numerator is equal to the denominator, then I look at the coefficients. So first, let's find our vertical asymptotes here. So I set the denominator equal to 0. So I have 5x plus 2 is equal to 0. Subtract 2 on both sides. So 5x is equal to negative 2. Divide by 5, x is equal to negative 2 over 5. That's my vertical asymptote. For my horizontal asymptotes, I look at the degrees of my numerator and the denominator. So what's my highest degree term in my numerator? What am I looking at in the numerator? Highest degree term would be the 3x. And then in the denominator, it would be 5x. So are my degrees the same? Yep. So then I have to look at the coefficients. So my horizontal asymptote would be 3 over 5. Y is equal to 3 over 5. And then lastly, for domain, you set the denominator not equal to 0. So it would be the same work that we just did here, but it would be x does not equal negative 2 over 5. Which, if this question was multiple choice for domain, you could see all real numbers except negative 2 over 5, or you could see it as an interval notation, so from negative infinity to negative 2 over 5, and then from negative 2 over 5 to infinity, with the union in between. So it just depends on how it's written. Since it's multiple choice, you could see it this way. You could see it this way.
But how did you get the 3 over?
So for B, we do the same thing. So for my vertical asymptote, I set the denominator equal to 0. So x plus 2 is equal to 0. X is equal to negative 2. So that's my vertical asymptote. For my horizontal asymptote, my degree in my numerator is 2. My degree in the denominator is 1. So what is it when your numerator is greater than the denominator?
None.
No horizontal asymptote. And then for the domain, you just set the denominator not equal to 0. So this would be x does not equal -2. So you could see the domain written as all real numbers except -2, or it could be written as -infinity to -2 union -2 to infinity. So these are just two different ways of writing the domain. All right, let's look at 16. Use the given 0 to find all the zeros of the function. So if I know that -3i is a 0, I also know that 3i is a 0. Because if you have a complex number, its conjugate is also one of your zeros. So this means that I have the factors of x plus 3i and x minus 3i. So I can FOIL these out as x squared minus 3i squared minus 9i squared. The I squared becomes a -1, so it becomes plus 9. So this is x squared plus 9. So this is a factor of my polynomial. How can I find what other factors are? So I would do long division. So you could use synthetic division, because all we need to do is divide. So we have to use long division because it is x squared. I'm just going to write it outside here. So this is x squared plus 9. That divides into this. So what times x squared gives me 2x to the 4th power? 2x squared, awesome. So I'm going to put that x squared on top of the x squared column. So then I multiply 2x squared times x squared, which would be 2x to the 4th power. And 2x squared times 9 would be 18x squared. I have to change the sign and then combine. So I'm going to drop down this x cubed. This would be minus 3x squared. So then what times x squared gives me 3x cubed, or it gives me x cubed? X. So next I have plus x. Multiply. So this would be x cubed plus 9x. Change the sign, and combine. So I'm going to drop down the 3x squared, negative 3x squared. Positive 9i and negative 9i, positive 9x and negative 9x cancel. So this is negative 3. So then multiply, get negative 3x squared minus 27. Change the sign, combine. These cancel and these cancel. Which it makes sense that they cancel because we already knew that this was going to be a factor. So it was already going to go in evenly because it was a factor. So now I have 2x squared plus x minus 3 as another factor. Can I factor this more? Yeah? How do I factor when I have a number that's not 1 to start? Multiply the first and last. So 2 times negative 3 would be negative 6. Two factors of negative 6 that add to 1. Positive 3 and negative 2. So this is x plus 3 and x minus 2. What's one thing I have to remember to do when I start by multiplying? I have to divide the first number. So if you start with multiplication, you have to go back in and divide. So this is 2x plus 3 and x minus 1. And then just set each piece equal to 0 and solve for x. So x is equal to negative 3 over 2, and x is equal to 1. So this is a 0, this is a 0, this is a 0, and this is a 0. A helpful hint, I think, when taking your midterm, it's multiple choice, so it'll give you answer choices. So one of your answer choices will have all 4 of these zeros here. Instead of doing all of this work and foiling, then dividing, then factoring, you could always just take one of your zeros that is in the answer choice. So let's say we had x minus 1, and we can do synthetic division into the original equation, and if we get a remainder of 0, then we know it's a factor. So if it gives you your answer choices, you can always do long division to check and see if it's a factor or not. So I found that to be super helpful when I was doing the answer key to the midterm. I just did long division, or synthetic division over and over, like anytime that it asks you to find the zeros. Yeah. Just to test our theory, let's do synthetic division here. So I'm going to do 1 since it's a whole number. So I have 2, 1, 15, 9, and negative 27 that goes in the box. So I just put inside the box my coefficient. So 2, 1, 15, 9, and negative 27. So we're going to do synthetic division to see if this is a factor or not. So just checking our work. Working backwards. Drop down the 2. Multiply, add, multiply, add, multiply, add, multiply, and we get 0. So 0 means that it is a factor. So just showing you a little shortcut for your midterm. So number 17 says divide the polynomial using long division. So if it gives you a trinomial to divide into a polynomial, you have to use long division. Synthetic division doesn't work for trinomials. So outside we put x squared minus 5x minus 1. Inside our box we would have 5x cubed minus 21x squared minus 25x minus 4. So what times x squared gives us 5x cubed? 5x. So then multiply 5x by everything out front. We get 5x cubed. 5x times negative 5x would be negative 25x squared. And 5x times negative 1 is negative 5x. Change the sign, change the sign, change the sign, and combine. So these cancel. I get 4x squared minus 20x. What times x squared gives me 4x squared? 4. So the next side I have plus 4. Multiply. I get 4x squared minus 20x plus 4. Change a sign, change a sign, change a sign. These cancel, and this should be plus. These cancel. So then my remainder is 0. So this would be my answer. 5x plus 4. All right, 18. Use the remainder theorem and synthetic division to find the value of the function. So to evaluate the function at this value, we can just do synthetic division. So outside I would put negative 6. Inside I have 2, 11, negative 21, and negative 90. Drop down the 2, multiply, add, multiply, add. I get 15, negative 15, multiply, 90, add, we get 0. So the remainder theorem is whatever your remainder is, that's your answer. So here, f of negative 6 is 0. So if you were to plug negative 6 into all of your x's and evaluated it that way, you would get 0. Bless you. All right, 19. Show that x is a solution of the third degree polynomial equation and use the result to factor the polynomial completely. List all the real zeros of the equation. So to figure out if 3 is a solution, I'm going to do synthetic division. So put 3 on the outside, Inside the box set I have 1, -1, -9, and 9. Drop down the 1, multiply, add, multiply, add, multiply, and I get 0. So when I get 0, that means that it is a factor. So it works. Now to find the remaining factors, I use the coefficients of what it gave me here. So this would be x squared plus 2x minus 3. So what are two factors of -3 that add to 2? +3 and -1. So this would be x plus 3 and x minus 1. So set each one equal to 0 and solve for x. So x is equal to -3 and x is equal to 1. So those are my 3 solutions. All right, 20. Given x minus 4 and x minus 3, find the remaining roots, write in fully factored form. So I know that these two are zeros, so I need to find the remaining. So I just want to factor this to get it smaller. What I could do is just take one of these zeros and use synthetic division and find what the remaining are, or I could FOIL these out and then use long division to divide, but synthetic division is a lot easier, so we'll do that. So let's say I take x minus 4. What goes outside the box? +4. Awesome. Then inside I would have 1, -5, -2, and 24. Drop down the 1, multiply, add, multiply, add, multiply. I get 0, which was the goal, because I already knew that it was going to be a factor. So now I have x squared minus x minus 6. I could do synthetic division again with this and then find whatever's left, or I could just factor this. So what are two factors of -6 that add to -1? +3 and -2. -3 and +2. So x minus 3 and x plus 2 equals 0. So I have x is equal to 3, which I already knew that from here, and then x is equal to -2. So in fully factored form, this would be x minus 4, x minus 3, and x plus 2. And if I was just writing my zeros, that would be x is equal to 4, 3, and -2. All right, 21. Next page. Describe the transformations. So what does this negative being multiplied outside do?
Reflection.
A reflection. What about multiplying by 3 on the outside? Is it a stretch or compression? Stretch. What about adding 4 on the inside? Left 4. And then subtracting 1. Down 1. All right, 22. 22, A and B are multiple choice. So A, I have to put it into logarithmic form. So I start with log. Whatever the base is here is going to be the base of my log. And then you just flip the other two numbers. So it's 4, then 64, and then 3. So the way I think about it is that, like, I have 4 to the power of 3 here. It's going to be the opposite number when it's here. So it's never going to be like the same, just repeated. So it wouldn't be 4, then a big 3. So you just flip the other two numbers. So here, my answer choice is B. And then for b, I have log base 5 of 1 over 125 is equal to negative 3. So that would be answer choice D. Any questions here? All right, 23. Again, these are multiple choice. So here we're putting it into exponential form. The base of your log is your big base now, and then just switch the other two. So 4 to the power of 3 is equal to 64. So that would be C. Second one, make your base of log your big base. So 5 to the power of 3 is equal to x. So that would be B. All right, 24. Anytime you have an exponential graph, it's easiest just to plug in values for x and y. Plug in values for x, get values for y. So you can plug in -1, 0, and 1. So this would be -3 to the power of -1 plus 2. So -1/3 plus 2. So you could just go to the left to -1, and then you would go down to -1/2, but plus 2 would mean to go up 2. So it would just be a little bit less than 2 here. And you guys also have a calculator for the midterm, so you could always put that in your calculator. Next, we're plugging in 0, so -3 to the power of 0 plus 2. This would be 1 plus 2, which is 3. And then plug in 1. So -3 to the power of 1 plus 2. So this would be -3 plus 2, which is -1. I graphed this point wrong. This one should be -1, so it should be 1. Because the negative's on the outside. So this one should be 1, and then the other one is -1. So your graph would look like this. All right, so 25. Determine the zeros. So how do I find the zeros here? I just need to put the numerator equal to 0, because if the numerator is 0, then the whole thing is 0. So 2x squared is equal to 0. Divide by 2. X squared is equal to 0. So x is equal to 0. So the 0 here is 0. Okay, any questions here? Right, so if our 0, like whatever makes the top 0, it can't make the denominator 0 also, because that would be undefined. So you can always just double check the denominator by setting that one not equal to 0. So if this asks for like the domain, we would set the denominator not equal to 0, and we would have to state our domain. So x cannot be plus or minus 5. But here, all it's asking for are the zeros, so what makes this 0 are y. So all you need to do is set the numerator equal to 0. All right, 26.
Isn't there a rule that it can't be the thing, the denominator, or it can't be a 0 that...
All right, so 26. So we can't have I in the denominator, so we have to multiply by the conjugate of the denominator. So we're going to multiply by 3 minus 3i on the top and on the bottom. So on the top, we just need a FOIL. So 5 times 3 would be 15, minus 15i, minus 12i, plus 12i squared. What does I squared turn into? -1, so this becomes a minus 12. We can combine like terms, so 15 minus 12 would be 3. And then negative 15i minus 12i would be minus 27i. So that's our top. On the bottom, we FOIL also. So 3 times 3 would be 9. The outer and the inners are going to cancel. So you can multiply 3 times negative 3i and 3i times 3. They'll cancel out. But when you multiply by the conjugate, the outer and inner always cancels. And then the last ones would be negative 9i squared. What does I squared turn into? Negative 1, so it makes it a positive 9. So on the bottom we have 9 plus 9, which is 18.
Can't you simplify this?
Can I simplify the fraction? Yes. So everything is divisible by 3. So this would be 1 minus 9i over 6. Yeah.
Can you just write negative 9i over 6 if you have to?
You have to put the 1. So it could be written like this, or it could simplify it more as like 1 over 6 minus, and then 9 and 6 are both divisible by 3, so that would be 3i over 2. Could write it like this too. So if it's multiple choice, just make sure you check out the answer choices and see, is it simplified even more? If it's not multiple choice, this is fine as an answer. All right, next one, number 27. So we have 7 minus 5i squared. We have to multiply this times 7 minus 5i. So it's 7 minus 5i times 7 minus 5i, because squared just means we multiply it by the same thing. Then we need a FOIL. So this would be 49 minus 35i minus 35i plus 25i squared. What does the I squared turn into? Negative 1, so this would become minus 25. We can combine like terms, so 49 minus 25 would be 24. And then negative 35i minus 35i would be minus 70i. Remember when writing these, standard form, you always need to put the real part first, then the imaginary. All right, 28. How can I solve? What do I need to do? Awesome. So I want to take log base 5 of both sides, because that way log base 5 of 5 will cancel. So then on the left side, I'm just left with 3x. And on the right, I have log base 5 of 6. Anytime you have exponents, like if x is in the exponent, you want to do the inverse of exponents, which is logs. So if x is in your exponent, you're most likely going to take the log of it to get it to cancel. And you always want to take whatever your base is here, the log with that base, so it'll just cancel out.
Okay.
So then I have 3x is equal to log base 5 of 6. I can put this in my calculator, but it has to be log base 6 over log base, or log of 6 over log of 5. So this is what you would put into your calculator. I think when you put that in the calculator, you get 1.1. 1.1-ish. And then divide both sides by 3. So what'd you get for x? 0.37. So in your calculator, you have to do log of 6 divided by log of 5, because that's our change of base formula. And then once you put that in the calculator, you have to divide it by 3. All right, next, we have to find the y-intercept. So the y-intercept is when we make the x-intercept is when we make y 0. So we have to find the x-intercept, so we're making y 0. So I have to solve for x here. What do I need to do to solve for x? So ln is technically a log.
Oh,
Logan, what do I do?
log of y, too.
The e, I make the big base e. Because ln is the natural log, so that's like saying log base e. So to do the inverse of log, I'd make the big base e. So this cancels. So I have x minus 7 is equal to, what's e to the power of 0? 1. Anything to the power of 0 is 1, but you could also put that in your calculator, you'd get 1. And then you just add 7 to both sides. So x is equal to 8. It asks for the x-intercept, so it may have your answer as a coordinate point, so that would be 8, 0.
Wait, how did you get the 1?
All right, for number 30, we're doing the same thing, so we have to find the x-intercept, so we make y 0. So I'm making y 0 here. So what can I do to get rid of that log? Make the big base 2. So 2 to the power of log base 2 cancels, so I'm just left with x minus 2. And what's 2 to the power of 0? 1. Anything to the power of 0 is 1. And then I just solve for x. So add 2 to both sides. X is equal to 3. What do I need to do here for 31? The logs cancel. So when your logs are the same, they just cancel. If you have a log is equal to a log, you can get rid of them. So 5x minus 7 is equal to 2x plus 5. Then we just solve for x. So subtract 2 on both sides, 2x, add 7. So I have 3x is equal to 12. Divide by 3. X is equal to 4. All right, 32. Find the domain and the vertical asymptotes of the logarithmic functions and then graph. So our basic log graph, if we just had log base 5 of x, that looks like this. But here we have a plus 3, so which direction does that plus 3 move our graph? To the left 3. So we move 1, 2, 3 to the left, and then our graph would just go through that point. So instead of our vertical asymptote being through 0, if I moved it to the left 3, what's my vertical asymptote through now? -3. So my graph goes through -2, but my vertical asymptote was at 0, and I moved it to the left 3, so now it's at -3. So vertical asymptote would be x equals -3. And then what would my domain of my graph be here? Just remember, domain is from left to right. Awesome. -3 to infinity. Because it starts at -3 and then it's pointing forever in the right direction, so it goes to infinity out here. So 33 is multiple choice also. So log base 9 of 9. What's our answer? 1. Awesome. Because log base 9 of 9, this 9 has an exponent of 1, so log base 9 of 9 cancels, and we're just left with 1, so that would be D. If I had, let's say, log base 2 of 2 to the 5th power, log base 2 of 2 cancels, so then my answer would just be 5. So it's whatever your exponent is your answer. Yes. All right, next we're converting to radians. So multiply by pi over 180. You guys can have a calculator, so you can simplify in the calculator. 45 goes into 225 5 times, and it goes into 184, so this would be -5 pi over 4. Convert to degrees, we multiply by 180 over pi. So the pi's cancel, 6 goes into 180 30 times, so 30 times 11 would be 330 degrees. Right, in 36, we have to find one positive and one negative coterminal angle. So positive, we add either 360 or 2 pi, and negative, we subtract 360 or 2 pi, depending on if it's degrees or radians. So -125, we add 360. So this would be 225. 225. To find the negative coterminal angle, we can subtract 360. So this would be negative 485. So there's our positive and negative. We do the same thing for b, but just with the radians. So add 2 pi. When adding fractions, we need our denominator to be the same. So I'm going to make this 14 pi over 7. So just multiply the top and the bottom by 7. So this would be 25 pi over 7. And then I just need to subtract 14 pi over 7. So this would be negative 3 pi over 7. So just remember, 360 is 2 pi. For 37, we have to find the complement and supplement. So complement, they add up to 90, or if it's in radians, pi over 2. Supplements, they add up to 180, or pi. So for the first one, we have degrees. This would be 90 minus 104. We get negative 14. Can I have a negative complement? Nope, so there would be no complement. For the supplement, I have 180 minus 104, which is 76. So that's my supplement.
Supplement can't be negative either.
Right, supplement can't be negative either. Number 10, we're doing the same thing but with radians. So I have pi over 2 minus 3 pi over 4. So I have to multiply the top and the bottom here by 2. So 2 pi minus 3 pi would be negative pi over 4. Can I get a negative? Nope. So there would be no complement. And then for the supplement, it's pi minus 3 pi over 4. So this would be 4 pi over 4, which gives us pi over 4. So find the arc length of the sector with the given info. So our arc length formula is S is equal to R times theta. Whenever we use this, theta has to be in radians. So first thing I need to do is convert 225 to radians. So multiply by pi over 180. We would get 5 pi over 4. So S is equal to R, which is 6, times 5 pi over 4. So this would be S is equal to 30 pi over 4, which simplifies to 15 pi over 2. But if this were multiple choice, it could either leave your answer like this, or it put it in the calculator. So you just do 15 times pi divided by 2. All right, 39 is the same thing. So we're using S is equal to R times theta again. So 8 is equal to 6 times theta. So divide both sides by 6. Theta is equal to 8 over 6, which is 4 over 3. This is in radians, because anytime we use the formula, it has to be in radians. The question asks us for radians, so we're good. So this is our answer, 4 over 3. If the question asked us for degrees, so if it said find the degree measure of the central angle, we would have to convert it to degrees. All right, 40 was from our last chapter. So a point on the terminal side of angle theta is given. Find the exact value of the indicated trig function. So this would be to the right 9 up 12. So 9, 12, this would be our point here. It's asking us to find cosine, which cosine we know is adjacent over hypotenuse. So we have the adjacent, we just need to find the hypotenuse. So what can I do to find the hypotenuse? Pythagorean Theorem. So 9 squared plus 12 squared equals x squared. So 81 plus 144 is equal to x squared. So 225 is equal to x squared. Take the square root. X is equal to 15. So our hypotenuse is 15. So our cosine of theta is what? 9 over 15. We can simplify this, so cosine of theta is 3 over 5. Just divide the top and the bottom by 3. The last thing we always want to check for these is our signs. So we have all students take calculus. We're in the first quadrant, so all of them are going to be positive, so cosine's positive. If I were in the second or third quadrant, cosine would be negative, so always just keep an eye out for that at the end. All right, so 41. What do I need to do to solve for x? Awesome. Divide by 4. You want to get your exponent, the x with the, whatever number has the x in the exponent all by itself. So we're going to divide both sides by 4. So I have 8x minus 1 is equal to 8. Now what can I do? What do I do? I can take log base 8 of both sides. That works. So this would be x minus 1 is equal to, what's log base 8 of 8? 1. Perfect. And then we just add 1 to both sides, so x is equal to 2. Another way we could have done this, if I had 8 to the power of x minus 1 is equal to 8. The 8 on the right has the exponent of 1. So since I have the base of 8 and the base of 8, they cancel. So then it's just x minus 1 equals 1. So it's essentially the same, but just a little bit different. Whenever you have the same base, you can cancel them out. It would also always work if you just took the log of both sides, because then the log will cancel it out. All right, 42. So I'm expanding. So when expanding, we know if we're multiplying, that means we have to add. And if we're dividing, that means we have to subtract. So I'm dividing in the middle. So I'm going to separate those by subtraction. So I have log base 7 of 40x cubed minus log base 7 of z to the 5th power. Every time you break something apart, it needs its own log. I'm also multiplying here in between 40 and x cubed. So how do I break those apart? By adding. So this would be log base 7 of 40 plus log base 7 of x cubed minus log base 7 of z to the 5th power. And then the last step, what do I do with the exponents? Bring it to the front. So it goes to the front of the log that it's attached to. So this would be log base 7 of 40 plus 3 log base 7 of x minus 5 log base 7 of z. All right, 43, we are condensing, so we're bringing it together to be one log. So first thing I want to do is move the coefficients out front to the top. And then if I'm adding, what goes with addition? Multiplication. So this is log base 8 of x plus 3 to the 5th power times x minus 6 to the 1/3 power. So your answer could be written like this. If it were multiple choice, it could also be written as x plus 3 to the 5th power, and then the cubed root of x minus 6. Because remember, the exponent of 1/3 is the same thing as the cubed root. So these are the same. All right, 44, we have to state the quadrant. I spelled this wrong, but it's fine. Where theta lies if sine is greater than 0 and cosine is less than 0. So we have all students take calculus. Sine is greater than 0, so which two can I cross out? 4 and 3. So sine is greater than 0. What about cosine's less than 0? Which one can I cross out now? 1, because it's not going to be an all if cosine's less than 0. So that means that we are in the second quadrant. 45, graph the function. So this was on our last test. We need A, B, C, D, starting point, the period, and the increments. So A is what? 3. B, 4. C, pi. And D is 0. So our starting point is C over B. So that would be pi over 4. So we're starting here at pi over 4. It's cosine. So do I start at 0 or start at the amplitude? Cosine. Start at 0 or start at the amplitude? Start at the amplitude. So cosine means that I start at the amplitude. And I start at pi over 4. So that's right here. The period is 2 pi over b, which b is 4. So this would be pi over 2. And how do I find the increments? Period over 4. So pi over 2 divided by 4, which would be pi over 8. So starting with the starting point, which is pi over 4, I add pi over 8 to each increment. So I need a common denominator. I'm going to make this 2 pi over 8. So this would be 3 pi over 8, which I think puts us right here. So this is 3 pi over 8. So then 3 pi over 8 plus another pi over 8 would be 4 pi over 8, which is pi over 2. So then I go down to negative 3. So then 4 pi over 8 plus pi over 8 would be 5 pi over 8. So I can just make that my next increment, 5 pi over 8. And then 5 pi over 8 plus pi over 8 would be 6 pi over 8. So this would be 3 pi over 4. This would end up back up top. So we have our starting point and 4 points after that. So that's all we need for one period. And we can just graph there. So it tells us that angle A is 40 degrees. Angle B is 46 points, or not angle B, but side B is 46.6. And we have to find A. So which trig function do I need to use to find A? Tangent. So the tangent of 40 is equal to opposite over adjacent. So that would be A over 46.6. So solve for A. I multiply both sides by 46.6. So A is equal to 46.6 times tangent of 40. And I would put that into my calculator. So we get 39.1.